So I guess I should actually say the project is called Ironic, not just bare metal provisioning. And a little more about me. Before this, I worked at Percona. Before that, some other companies that were kind of interested in running lots and lots of things at web scale. And so a lot of the same principles I've been applying here. And kind of the story of this project really starts in Seattle, chatting with Monty and Robert and other people, bemoaning the fact that the folks who were in the data centers provisioning bare metal using homegrown Pixie tools or things like crowbar, whatever else, they're not getting the benefits of running things in a cloud and orchestrating large-scale deployments in the same way that folks in clouds are. And that's kind of annoying, I think, and unfortunate. And I wanted to solve that. And we sort of noodled on how could we do that. What we're really missing is, we're working on OpenStack. OpenStack lets people orchestrate things well, but it doesn't have a way to control hardware yet. What if it did? Wouldn't that be cool? And then we found that there was some folks in Japan and Korea and also Southern California working on a driver for OpenStack Nova, OpenStack Compute, to let it control hardware. So we went to the Portland Summit, San Diego Summit. Which city is that? San Diego. And had a nice chat with the folks from NTT Docomo and USC-ISI and Virtual Tech Japan, and said, hey, we've been playing with your sort of prototype driver, your fork on GitHub, and we proved that it works in our little labs, and it's great and awesome. How can we help? And they said, we don't have enough time to really keep pushing this forward. Do you guys want to take over? Sure. OK. And so I spent a bunch of time, along with Chris Crelly, working on the driver, refactoring it, cleaning it up, proposing it to Nova, getting it merged. Yay. Thus was born the bare metal driver. So this is what? This is about a year ago, and I think I was here at the mini-conf last year talking about what we were doing with bare metal provisioning. At that point, it was just a driver for Nova Compute. And so you change it from libvirt or Zen to bare metal, and you could have Nova provision machines. It's a great proof of concept. Of course, we had to change some things in the plumbing of Nova to make it work because hardware is different than VMs. Just fundamentally, it's got some constraints. Like you can't generate a MAC address and define your VM to have that MAC address. You have to actually ask the machine or really know ahead of time what's the MAC address and pass that out to your networking layer, neutron, quantum, et cetera. And some other things. We needed to add a second database backend to Nova, which kind of sucked. Most projects in OpenStack that have a database want to have one database for that project. We had to add a second one. It wasn't good. I want to rip that out. We're going to do that soon. We had to create a new scheduler. So so the reason for this was with VMs, right? You can take a chunk and say, here's my machine that I'm running libvirt or Zen on. I'm going to allocate 4 gigs of RAM or 16 gigs of RAM. And so the scheduler is making decisions based on partial resource allocation. With bare metal, you get the machine. That's it. So we had to replace the scheduler. One of the side effects of this is you couldn't run virtual and physical schedulers in the same region of Nova. Again, suck. And you have to run an extra service and a couple other things as well. And again, not really part of what makes Nova happy. Normally run Nova this way. Oh, wait, bare metal, have to run it that way. So I was not happy with all that. It was promising. It was enough to enable Robert and all the OOO stuff to prove itself and be awesome and great, but we hit a lot of walls. Folks who wanted to add features to it, us and others, really couldn't expand it because it's constrained by Nova's mission. This is different. And HA, right? The entire HA model for provisioning bare metal versus managing VMs is different. We tried to think about it, how to do it internally inside of this extra service or the driver in Nova Compute, but really it came down to we had to wrap it around the outside. Not good. In addition to having the scheduler problem, you could only run one driver. So if you wanted to control different kinds of hardware, ARM versus x86, you'd have to run different Nova computes with different properties. That might be wrong. That should be per Nova compute. No, that might have had to be scheduled as well. Yeah, issues. And so progress on this was blocked for a while. And so at the Portland Summit, I said, guys, I think we need to really rip this out and refactor this. And talk to people, and they mostly agreed that yes, OpenStack should have a bare metal provisioning service, both because that is useful for high performance compute, folks who want to internally use it for provisioning bare metal, and for OOO, the program, OpenStack provisioning. Having a layer of OpenStack that can provision or deploy images onto bare metal is an essential part of OOO. So people agreed, yes, this belongs in OpenStack, and made a new project. And that's the opening commit, because Monty has to touch everything. And he's really helpful. So of course, Monty's got the very first commit in, I think every project just about. No? Not yours. Oh yeah, OOO, a lot of them. And he was really helpful in getting this off the ground. Since then, that's less than a year ago, we've got more than 40 developers, more than 10 developers that have been there to do about 10 commits or more each. So pretty good diversity from a bunch of different companies. I'm really, really thrilled about that it's not just me and it's not just HP. We've got Red Hat and IBM and Mirantis and a bunch of other folks really digging into this. And that makes me really happy. So that was last May. Yeah, May's when it started. It's now January. A bunch of stuff's happened. We've been working on this. It's still not integrated. It's not in a release yet. But Hong Kong 2 months ago, the last summit, the most recent summit, one of the really big topics that kept coming up at the Hong Kong summit, and anyone who, I'm curious, who all was here at the or was there for the OpenStack summit in Hong Kong? About a third of the room, okay. How many of you saw how many of the keynotes touched on OOO? Kind of a lot? Yeah.
I thought it was funny. But that's because I'm from Susan and we use crowbar already.
So I thought it was really awesome, really cool to see OOO just getting sort of this broad recognition that OpenStack needs a way to deploy itself. There needs to be part of this OpenStack project is a unified way to deploy it, or not as in, the chef puppet debate can be there. That's fine. That's your configuration management. But one of the things that I think is a blocker to adoption of OpenStack is that it's really complex to install right now. And having a simpler way to install it would really help its adoption. To do that, it has to have a way to control bare metal. During one of the keynotes there, this jumped out at me. OpenStack is not a virtualization layer. When I came on 2 years ago, that's how I thought of it. It virtualizes compute resources, it virtualizes storage, etc. It's really an abstraction layer. In this case, one of the reason this distinction is important is bare metal. You're not running things virtualized. It's just abstracted what the resource is. For most other hypervisors, this is what a deployment process would look like, right? You send a request to the API, Nova does its thing, talks to the services, talks to hypervisor, you get some compute resources. From the user's perspective, that's the normal workflow. Is anyone not familiar with this workflow? Good. No hands went up. Okay. With Ironic, it's the same, really. From the user's perspective, it's going to be the same workflow. There'll be a little bit of different stuff at the management layer beforehand to enable Ironic to do that. But really, your boot request comes in. Nova API, Nova scheduler. The scheduler picks a node, sends it off to a compute. The Nova compute is just a really thin shim here. Passes it off to Ironic API, which sends it off to a conductor. The conductor passes it to a driver. And there can be many drivers. I'm going to spend a little bit of time kind of digging into this slide. And probably the next 20 slides talking about this slide. Because this interaction here is where we're spending a lot of engineering time. How to manage failover, how to manage many different drivers, how to enable vendors to add drivers for their hardware. That was, like I said earlier, one of the limiting factors with when we had this in Nova. It was not easy to support different drivers. It took a config file option. So each Nova compute process could only manage one class of hardware. With Ironic, this conductor can have as many drivers as there are that can all be running in parallel on each conductor, and there can be many conductors, managing heterogeneous hardware. So you have some C-micro hardware, some IBM hardware, some HP hardware, and they can all be managed in the same control plane and abstracted from the user. The user might be ideally like your ops team who wants to deploy an application on these racks of servers. Once it's all configured, they don't have to be as mindful of exactly where it's going. Maybe they want to know, but the tooling is simpler, makes the automation easier, means you have more consistent results. Another thing we're doing, right here, Nova Compute had to talk to all these other parts of OpenStack. Now we do. Ironic should be talking to them. So Ironic will pull images directly from Glance or Swift. Ironic will tell Neutron, hey, when you get a DHCP boot request on this machine, route that over here. And that plays into our failover model, our fault tolerance in Ironic. That if a conductor fails, another conductor can take over for it and can take over the active deployments for it. What does it have? Oh, right. So I just tossed a slide in there a few minutes ago. It's worth pointing out that there's no hypervisor. Here, hypervisors between the tenant and the bare metal. Here, no hypervisor. Your image gets deployed directly on bare metal. The tenant runs on bare metal. No hypervisor. Giant security hole. If you don't trust the tenant, that is terrible. So don't do bare metal as a service for public cloud. Just please don't do it. We're not there yet. I know there are folks working on the security for that. Not yet. It might be a while. So the flip side of this is, why? This is great if you trust your tenants. If your tenant is, in fact, your company, what you're deploying is a well-known workload, whether it's high-performance compute, it's all internal, or you've got some different divisions of the company that need resources, that need maybe GPU pass-through, or just want much better performance to run a database on physical machines instead of a VM, but it's all internal. It's a provisioning layer for that. Or maybe you want to create a public cloud, or private cloud, or whatever, and you want to orchestrate and manage the deployment of that cloud, i.e. OOO, pointing at Robert. And that really ties back to this quote that really cemented it for me when I heard that in a keynote a few months ago, that this is an abstraction layer. This is enabling some new things. Okay, going to the meat now, the driver interface. I know I mentioned a couple times there could be different drivers. It could be driver for IBM or HP or whoever with different hardware heterogeneously. There's a strict interface inside of Ironic for each driver that has 3 classes of interfaces. Core, if a driver exists, it must implement these interfaces. Common, a driver may or may not implement these. If it does, it must adhere to the API spec. If it doesn't, that's okay. If it doesn't implement them, that's okay. It can just be stubbed out and null, not supported. And vendor pass-through. And this is this is an undefined part of the driver interface. It's left there for vendors to break new ground, for people to add new functionality that no other driver has, rather than trying to define an interface and make everyone else adhere to it because you're the first one there. This is a space for vendors to add new functionality. And my hope is that as vendors add new functionality, we'll see that a lot of them implement very similar things, and we can draw those implementations back into the core of the driver API. So what are these interfaces? Power management. Turn it on, turn it off, reboot it. Pretty simple. Oh, and get the power state. Kind of need to know that. Deploy. Prepare the deployment environment, actually put the image on the machine, tear the image off the machine, and clean up the deployment environment, basically. And there'll be a few other hooks in there for node takeover, et cetera. What are the common interfaces today? Console support, serial over LAN, things like that. If a driver doesn't implement those, it's not the end of the world. Most of OpenStack will still work. All the abstraction layer of provisioning a physical machine is intact if we don't have console support. Same for rescue, but it's great if they're there. And the vendor interface, and that is, right now, like our reference implementation of the Pixie and IPMI drivers doesn't have vendor. It uses vendor pass-through in a way, but not really there. I'm waiting for vendors to come add things, like possibly firmware management or boot from volume. And there's interest from folks in both of those right now. Something else, I don't know. We'll see. What does the architecture look like? This has been an evolution. Again, the project's only 8 months old or so, but today it looks like this. There is a RESTful API, and most importantly, you use that to enroll hardware. You have to tell Ironic, here are the MAC addresses, here are the IPMI credentials, whatever it's going to need to manage that hardware. An admin has to enroll it. By admin here, I mean someone with a Keystone admin account, cloud admin, not the end user who might be issuing a Nova boot. There's a privilege separation there. There's an RPC layer, there's a database, and then the conductor that I mentioned. And I'm trying here to represent that these different colors are different drivers, but actually on each little block is a different instance of the conductor. So you can have multiple instances managing shared hardware, multiple drivers, and it all knows how to route requests from the API out to the appropriate conductor to manage the appropriate piece of hardware. And then if any of these fail, other conductors of that driver, or that have that driver enabled, can take over the hardware. And so I've been trying for months now to come up with a good graphic for that, and I really haven't. I don't think that's a great explanation for it, because it's not 2, it's not 3, it's dynamic. Conductors can join the cluster, they can leave the cluster. It uses a distributed hash algorithm to figure out dynamically which node should be managed by which conductor and route requests. So each conductor advertises a list internally of what drivers it supports, what are enabled. Nodes are mapped across that, and they can be remapped across that. That mapping is also exposed to the API tier. There is a distributed lock implemented such that if a remap occurs mid-operation, whoever just took over the node has to wait. So if you're doing a firmware update or you're mid-deploy, there's a lock around that, so no one else will attempt to interrupt it. And then we've got work going to how to recognize when something failed and recover a broken lock. And some of the actual RPC routing stuff is still in flight. Not all the code has landed yet. What if the cluster changes? Right, so the consistent hash will update automatically once it recognizes a timeout, a timeout window has expired, and that's synchronous across the cluster. Synchronous not in a broadcast sense, but in that assuming you have NTPD running and all the hardware clocks are in sync, synchronous in that sense. Nodes are remapped based on that. Oh, takeover hooks. So an example of that is for a PXE boot, when the machine turns on, it's going to send out a DHCP request. Neutron will pass that DHCP request to the appropriate conductor node that has, at that moment in time, announced its responsibility to PXE boot. If another node takes over, another conductor takes over, it has to inform Neutron to reroute to DHCP. So that's an example of a takeover hook. And again, that's pluggable in the driver interface. So different drivers might have different takeover hooks there. There is definitely still some work to do. It's fairly young. I'm really hoping that we'll have all of this done in the next 2 months. Yay. Right, now that was an exaggeration. I'm really hoping we'll have enough of this done in the next few months to replace Nova baremetal, be functionally equivalent, and let people start really using this and kicking the tires and adding new features and adding support for different hardware, and then see how it evolves from there. I'm ahead of time, as usual.
You've got quite a bit, actually.
Quite a bit. I went way too fast.
Yeah.
I tend to go really fast.
We're going to 14 minutes.
14 minutes. Okay. I can jump back and talk about things, or people can ask questions if there are questions.
There was one thing that confused me a little.
Yeah.
You said Neutron would route the DHCP to the conductors, or does it direct where the TFTP requests will go?
So Neutron will route the PXE boot. Yeah. Yep.
Do you have any sort of plans for migration from baremetal to Ironic?
Yes. Do we have any plans for helping people who might be using Nova baremetal today to migrate to Ironic? The plan there is to provide some scripts to export data from Nova baremetal's database, import them to Ironic, as well as, of course, part of the deprecation would be removing those old databases. But the actual migration won't be seamless. You'll have to redeploy. Right? I'm not, it might be possible, but I'm not planning on letting Ironic just sort of seamlessly take over an existing deployment.
Although that would be quite cool.
It would be. It'd be awesome. If you want to do it. Great, but it's, yeah.
It should be doable through the API, right? Read one, write the other.
Yes, so the statement there was it should be doable through the APIs of Nova and Ironic, and yes, one could do some Nova baremetal node show, pull the information out, Ironic node add, and then sort of a Nova delete, Ironic deploy, to redeploy the same image to the same node. So there'd be a brief interruption on that instance, but otherwise it should be relatively seamless. I saw a question back there.
Yeah, so you were talking about various hardware vendors supporting it or putting some sort of contribution in to make sure that it works with their system.
Mhm.
How dependent do you see the system being on the various hardware vendors adding some extra instrumentation components to make it work?
Right. So the question, if I understood correctly, was how dependent do I think Ironic is on, or the driver interface is on each hardware vendor?
So new vendor X comes along or you start getting your hardware from new vendor X. Does an end user then have to go through the process of making sure that vendor X has the plug-in drivers to work with Ironic?
Okay.
Is it more generic than that?
So the what's up in OpenStack right now, the code we have is a reference implementation of PXE and IPMI. So most hardware, most x86 hardware should be manageable with PXE boot to put an image on it. We use a small init RAMFS, a small RAM disk. We PXE boot that RAM disk, expose the disks over iSCSI back to the control plane, DD the image onto the machine and reboot. And we're using IPMI for power control. So again, most x86 hardware, you should have all that functionality. I'm not aware of any that doesn't. ARM is going to be a little different. There's some work people are doing to enable ARM support. Windows, same thing. You need a little bit different it's a small change to let us deploy Windows onto a machine. Really what the driver extensibility is for is to enable vendors that want extra functionality, like the examples I gave, firmware management. You want to flash to different firmware, or change BIOS settings on the fly. We can't do that over IPMI.
When you go to enroll a new machine, obviously machines can have any number of NICs, any number of disks, all of that sort of stuff. Do you have to supply that information, or is there any means to like get that stuff out of IPMI or any vendor-specific sort of tools?
So the question was, when you go to add new hardware, do you, you could have many different NICs with different MAC addresses. Do you have to inform Ironic of that information, or can it poll the hardware to get it, to discover it? And so the answer is right now you have to enroll it. You have to specify particularly the IPMI IP address, username, and password, and the MAC addresses for the NICs on the machine, such that it can control DHCP booting of those. Eventually, I would very much like auto-discovery and auto-enrollment, or auto-discovery, set it into a maintenance mode, have a user, have an admin confirm, yes, that really is the specs I expected for that machine. It's, it's JTAG, it's MAC addresses, it's so on, check against the factory manifest, and have a human confirm it, not just automatically add anything that DHCPs on your network. Yeah.
Questions? We have quite a few of the OpenStack team in here. Maybe there's some other OpenStack questions you guys would be happy to answer, or
Yeah.
if anyone has any generic kind of OpenStack questions?
Yeah. Or I'll take a break a little early.
Well, can I ask a question of the audience? Who here?
You are the audience.
But I can't answer this one myself. So who here is using OpenStack at the moment?
That doesn't work on the project.
Yeah, very good
All
point.
users are potential contributors.
Who wants to be using it, but isn't? Right.
Okay.
Thank you.
People working on the project?
So I'll repeat the question.
If you want to be using it and you're not, and you work on a project.
Robert. So I'll repeat the question for the camera. How many folks in the room are not currently using it and not developers who would want to be using it? And it's about a third of the room, I think, maybe a quarter, with their hands up. What was the next question?
Oh, well, that was the next question. But the follow-on to that would be why not?
The follow-on question is, why are you not using it now? And I guess that's actually eliciting answers, not just hands. So.
Why not? I need to blow away my ESXi instance before I can
You need more hardware?
We don't actually need to blow away to use OpenStack. As
course.
we've been discussing,
Of course,
it's
yeah.
hardware, it's hypervisor.
Yeah. Yeah. There's.
I don't use VMware. Is ESXi vCenter?
ESXi is vSphere, it's the hypervisor.
Right, so no, you can't do that. The only driver for VMware is a vCenter.
And vCenter is the management interface.
Yeah, you do. So the only way that Nova can talk to VMware hypervisors is via vCenter.
Yeah, okay, so if you have a VN set up on top of your
Yeah.
ESXi, example.
That's your money.
Yeah.
Yeah, that's right.
Okay, well, we can continue this.
Yeah.
Let's just say thank you, and on behalf of the RCA team.
Thank you.